AP style free response problem 14. Consider the reaction 2NO plus O2 produces 2NO2. These data were obtained from 3 experiments. You can see initial concentrations of the 2 reactants, and the initial rates of the reaction is also measured. So A, determine the order of the reaction for each reactant. B, write the rate equation for the reaction. C, calculate the rate constant. D, calculate the rate in moles, inverse moles per liter, inverse seconds at the instant when NO concentration is 0.015, inverse molarity, and oxygen concentration, oxygen concentration is 0.0050 moles per liter. And then E, at the instant when NO is reacting at the rate 1.0 times 10 to the minus 4 moles per liter seconds, what is the rate at which O2 is reacting and NO2 is forming? Okay, so first let's determine the order of the reaction. We've got to do that by comparing the experimental data. So let's look at reactions 1 and 2 first. So look what's happening here. The concentration is doubling. O2 staying the same, so we're only finding the impact on the NO concentration for now, or the impact that NO concentration has on the rate. So we have 2.5 times 10 to the minus 5 and 1 times 10 to the minus 4. So to go from here to here, what's happening to the rate? It is quadrupling. So if I double the concentration and quadruple the rate, we call that second order. So second order for NO. Now, let's compare reaction 1, or experiment 1, trial 1, and trial 3. So in this case, we're holding the NO concentration constant just to see what impact O2 concentration has on the rate. So from here to here, we are doubling. And in that doubled concentration, what happens to the rate? 2.5 to 5, it is also doubled. So we would call that first order for O2. Now that we know the order with respect to NO and O2, we can write the rate equation. So rate is just equal to K times the concentration of O2 to the first power times the concentration of NO to the second power. Once we find the rate law in part B, in part C, we can calculate the rate constant. So we're going to solve the rate law for K and then substitute any data from the experiment. And so in this case, we're going to use experiment 1. Okay, so we should see the rate is 2.5 times 10 to the minus 5. Concentration of O2 is 0.01. Concentration of NO is also 0.01, and then we should square that. And we get a K equal to 25 molarity to the minus 1 seconds to the minus 1. All right, in part D, calculate the rate in molarity per second at the instant when the NO concentration is 0.015 molar and O2 concentration is 0.0050 molar. So now that we found K, we can just substitute the values directly into the rate law equation. So K was 25. O2 concentration given is 0.0050. NO concentration given is 0.015. Don't forget to square it. Plug in those values. You get a rate equal to 2.81 times 10 to the minus 5. Molarity squared, seconds to the minus 1. So in part E, we're told at the instant when NO is reacting at the rate of 1 times 10 to the minus 4 molarity per second, what is the rate that O2 is reacting and what is the rate that NO2 is forming? So we can use our stoichiometry from the reaction itself to see that the rate of disappearance of the oxygen, because there's a coefficient of 1 here, is half as much as that of the disappearance of the NO, and that the NO and NO2 are a 1-to-1 ratio here. So for every 2 moles of NO that react, 2 moles of NO2 will form. So that rate will be the same. So for the O2, we just take half of the rate of the NO. So half of 1.0 times 10 to the minus 4, 5 times 10 to the minus 5. And for the NO, it's the same rate. So for the NO2, it's the same rate as the NO, 1 times 10 to the minus 4 molarity per second.